Hi, everybody. This talk is a continuation of the test and validation track. We're going to continue on the similar theme of how do you use LLMs to make your test and validation more intelligent and faster. The talk is titled Fight Fire with Fire, AI-assisted test debug flow and log analysis for AI GPU systems. So at Microsoft, myself, Anna Mary, I lead the AI systems team working on hardware systems validation and test. And with me today is my team member, Tommy, who is one of our GPU project leads. Moving on. Okay. So problem statement. As we all know, AI infrastructure is scaling at a very rapid pace and has massive validation data as we strive to qualify and test these systems before we deploy. Validation data uses heterogeneous formats. So if you're familiar with in-band and out-of-band data collection, every test toolkit that we use has its own unique format sets. There's a lot of standardization, as you have seen, happening on the out-of-band path, but the in-band has still a lot of way to go with respect to the diagnostics and other aspects that are collected through the in-band telemetry paths. Few of the key areas of debug that we had to face as we pushed out some of our latest technologies. If you have been to the Microsoft booth, you may have seen our GB200 solution. We ran into a number of different challenges. And we have pulled up the three main areas here, the first one being rack level. So rack level connectivity issues, especially with the back-end interfaces, scale up within the rack with proprietary scale-up technologies, as well as inter-rack and scale-out technologies were seen as we try to deploy it at volume. The second and more challenging at a node level or at a server level that we ran into was power envelope worst case scenarios. So you may have seen, talks and also looked at the power envelope of, the recent accelerator designs, and you see the TDP and the EDP profiles. There are unique challenges that we faced while we tried to debug the power envelope scenarios. The third and the more, I would say, more user customer-facing issues were around performance variations. As the software stack was evolving and we started running the newer models, we started to see a number of variations on the performance where we had to look into the hardware and tune it while we were deploying. So these were the three areas that we had to attack with volume data set. And the talk is going to give you a framework that we used with the LLM intelligence to tackle these challenges faster. This is, in a view, the test framework infrastructure that we used, and we'll be deep diving into each of these stages. The first step, obviously, is to define test cases. We are keeping this more agnostic to the domain. Maybe in the future we would come back and talk about a certain domain where we really adopted this for. But in this case, we used it exhaustively across all the three different areas that I mentioned in the beginning. So we had a test suite that was developed. We defined error signatures. So Tommy would walk you through what were the whitelist or the unique signatures that we caught, and we started adding it to the intelligence of this overall test debug flow. We had trigger scenarios to actually catch these issues and classify it, categorize it so that we can act on it smarter. The next step was log pre-search treatment, which means going through the logs, looking at these error signatures and treating these to make it more digestible to the overall framework. Then we had a log search, which we'll also talk further about. And then we do the good log versus known good log comparison versus what we got from that run. The final stages were towards post-search treatment, what we wanted to, in what format we were trying to spit out the analysis for EC consumption, log analysis, and stop on fail mechanism, because we really couldn't afford to waste time going back and rerunning that unique scenario, which would waste significant time in the development. And then the last step is to really notify the systems engineer to say, you have a failure and you need to quickly attack it with the logs that you have. Moving on to the first stage, defining the error signature file.
Yeah, so I'll be introducing this part. So to give a little more context, we are dealing with the racks of the GPU compute IT rack servers and the firmware components and the test tools and scripts. In order to exercise these components are massive. So I can say more than 50 number of these just the firmware alone. So our job is to stress these racks, with the power cycles and updates, and find the problem and to bring the debug to the next phase. So in order to achieve that, we introduce this log analyze and the debug flow. So that's a little bit of context. So the error signature file basically is to we have more granularity to provide it to the test engineers or debug engineers, so they can specify which log files, for example, the BMC CL logs, the Redfish events, or the Linux or Windows dmessage events, what log they are interested or concerning most, and define the error signature for each individual one. Some are very general, like the error keywords, and some are the error signature specific. The goal is to, define these error signatures, and also, with a whitelist, which take off the lines of the ones you don't want, and then filter out to have your remaining interested error signature matches. So that is the error, the error type error, and we also have error type good, which means you have to see a certain number of the good in your log. For example, you have to see a certain PCIe configuration, or your OS is in performance mode, things like that. Okay, so with those defined, this is the next step to do the data cleaning, to do the pre-search treatment. For example, you do the timestamp normalization, because for example, before your time is got synchronized, your BMC or system probably got a very early timestamp. So this is try to normalize those timestamps so that they can align, the logs can align. And then the second is very interesting. So I structure the data from like the JSON or XML format to a line-based, single line CSV format. Because this technology we are using is to do a line-based search. So pretty much the JSON and those structured log format we want to convert it to a line-based format, so we can do a better search. The third step, decoding, is also very key because like the SEL logs and CPR logs, and some case in our CPLD I2C dumps, those are not directly human readable. So we use related decoding tools to decode them to be human readable and the text searchable format. So the last one is optional, the log convergence. So in certain case, we merge the different source of the log together based on the timestamp. So we can have a single source of truth to review from the beginning to the end, to link different dots together. All right, so with all of this setup ready, so we do the log search. As I mentioned, you can see with the arrow signature type, the tool will find the related file and then find the match lines and take out those which is identified in the whitelist and you come to the result, which is the suspected error match. On the right side, the signature path, as I mentioned, you find some certain configuration or certain event log or test results log. You have to find some lines. Otherwise, you will consider this a failure. Yeah. So before I proceed to the next page, so this is we added recently to basically compare a known good log with the target log. This is in addition to the previously shared line-based log search, because in certain case, AI know better than our tool. So in this case, we prepare some good like power cycle. We know some even some lines have some suspicious, but we know they are good. So we highlight those, and so when the suspected log come out, we will do the log comparison. First, we need to take out some obvious not make sense. For example, the timestamp. If you compare two lines of log, the timestamp is obviously different, right? And some other example like the GPU number 1 and GPU number 4 is also, you don't have to worry too much about that. So we take out that as a log normalization, and then we do a fuzzy search. These are still local classic fuzzy search technology. And then based on the results, it can be very long, and we have our local hosted LLM server, and some of you may know this model have an upper limit of the context window. So we have to do some chunkization so that they fit in each chunk fit in the context window. And then we send this to the LLM to analysis, and let the AI to judge if these are good, suspected are good or not. All right, so back to the normal line-based search. So we will do some, after we do the log search, we'll do some cleanup, like group the suspected error message and deduplication. For example, yeah, there are lots of duplication, so we'll deduplicate that based on the fuzzy search result. And then we come to the final match result. Next page. Yeah, so in here we will, for the final filter result, we'll do first the local. We'll do a bug database search, which we have historical data, and then we'll do the knowledge, vector database search, which is the RAG. So we have some specs and troubleshooting guides, things like that. We'll search that, and then we'll send that to the LLM to do the AI analysis and summary to see if AI based on these contacts have additional suggests for the root cause analysis. All right, so the final is the notification. So as you can see, I was mowing the lawn, and the weekend I see some notification about this suspected error signature match. So we can get the result quicker.
Yeah. So how did we use this, right? Taking it back to the first three scenarios, we are pulling up two debug cases where we want to show how it helped us. The first one was we ran into a power delivery issue due to a faulty device on the power delivery board. We had a significant volume, and obviously the failure rate was very low. However, it was having significant impact because the node was not booting. So it was very difficult for us to really repro this in the lab because of the variability of the volume and all of that involved. How we handled it, going back to the block diagrams, we basically used the error signature in the database from the cell logs. We did all the post-processing that we mentioned in the different blocks there. and we really pulled up the error signature, right? So we understood it was on a certain device, it was hitting a certain issue, and that helped us quickly get into collecting more logs on that particular device. So it helped us with the result categorization, device level issue identification with the component not meeting the spec. If you remember, one of the blocks we had there was the spec. So we had the spec in there, and it helped us quickly correlate what was the parameter that was failing and what was the spec expecting of that device. And it helped us do the analysis pretty fast. So we were able to triage, debug it, and then also share this with the other configurations that were developed in parallel and influence the bill of material for the power delivery board to make use of the design change recommendation that was happening on our project, right? So in a traditional sense, this would have taken us very long to correlate everything together, but this framework, which is evolving, helped us debug and diagnose the issue pretty fast. Another debug scenario that we want to also highlight is link-related failures, right? So as you go to these high-speed networks, you have some that are proprietary, some that are standard link protocols. However, we started using this with link connectivity test failures, and it's really helped us even influence the quality of diagnostics the vendors were providing us from an accelerator standpoint to influence and say that, we are running into these buckets of issues, this is what we are seeing, and this is what we would like to see when we go ahead and hit some of these, right? So the log search helped us, and this was not a cell, it was a proprietary logging mechanism that the accelerator card had from a debug log standpoint. So we pulled that, we did all the post-processing, we pulled out all the relevant signatures out of it, along with the BER rates and all of that, and we compared it against the specs, and we were able to influence the design also to a certain extent because we were getting this data crisp and clean from the very early time of development and deployment. And we were able to group it, right, because obviously there were multiple underlying issues for the larger bucket. So we were able to group those signatures, have subcategorization, and also determine, as part of the result analysis, the defective test fixture or other things that had to go in to help fix the issue. So overall, we have actually contributed this back through GitHub. So if you would like to use it, you have the source code here. It's called the Log Analyzer code. It's under GitHub, Microsoft Log Analyzer. You'll have the source code and all of the nuances there. We would welcome industry adoption and also feedbacks or feature enhancements requests to this, because we believe as an industry, if we can build on our diagnostics capabilities, we are able to move faster. So we are looking forward to also participate in the OCP test and validation initiative and build on this for future generations of the accelerator developments. Thank you. Questions?
Yeah, one thing to add is the call to action is we want the, the silicon developers and system developers to provide the tools and the logs are easier to digest by the, the line-based search and also by the AI. You need to have some difference comparing with to the good log so that we can do the massive search. Thank you.
Yeah. Thanks for the presentation. I have a question about the final step when you realize a problem. Are you going through a React process, React cycle, a PNE, or it's just like then you start from the investigation? What I mean is that when you start to have the understanding of the problem and you do the root cause analysis, what reasoning kind of methodology do you use? You just go manually. You don't use LLM for the RCA itself.
Yeah, so it helps us give the different fishbone paths, if you will, to decide on the options that we have to pursue further. but it helps streamline what those critical, items are that we have to investigate further, right? And as we feed that into the LLM based on the search, next iteration around it becomes more intelligent because now it's looking for the subcategorization and then following the next steps, right? So it will evolve as it's as good as the data that you feed in from the test framework standpoint.
And the other question I have is with regards to the context engineering. So you have like, you start to get a lot of logs, and those logs you do, there is different method and draft. But so you kind of chunks what you need from the data. Mm-hmm. Do you have a specific process to manage the tokens you're sending to your engine, or?
Yeah, we just
you can do it offline.
We do a RAG search. We do a RAG search on the context, and then we send to the LLM. And the context window is our limit, basically. Thank you.
Thank you. Thank you all.